when you design something in the drawing, but it creates that from a real object. Then you can take that and put it into 3D printer and reproduce the object, or you can edit the object, cut off this bit, or add something, and make it. And this is kind of key to for many of the biological or medical applications of 3D printing to make prosthesis and so on. So when it gets it running, you can come up and you can have something scanned. Maybe what we can do is while he's setting it up, I can take some questions and then we'll take some fingers and we'll fire it up. Would that be good? So I'll take some questions. Thank you. Questions? Yeah.
3D printing can be legal, like legal guns, 3D printers.
It's a problem, yeah. Like every technology, unfortunately, he mentioned nuclear. That I had a meeting in the lab that developed nuclear fission as a practical thing. It has both peacetime and weapons applications. So like every technology, it always has applications that can be both good and bad. And we as a human race need to learn how to and you who are not scientists and engineers, need to learn to use the good and control the bad. So he mentioned that you can 3D print a plastic weapon. The moment we will figure this out, the moment cannot be easily detected by a metal detector. But of course you can develop other detectors that can detect this. So that's an example of a negative. And I can't think of any technology, unfortunately, which doesn't have that. So I wish it was different. And yeah, good question. Yes.
When you showed the 3D, the blue car.
Yeah.
Is this correct? All of the parts were made by 3D machines, but one machine did not make the car all at one time.
It wasn't made all at one time. You're quite right. In principle, that could be done. And for example, we have machines in the lab at the college which do have multiple printing going simultaneously. In fact, one of Sean's advisors' job is trying to figure out how to deal with multiple heads printing at the same time. But that's not how. Often you don't need to do that. It's much easier enough to. You're quite right. They would have printed parts of that car, the engine, the body, really different, and in pieces as well. They didn't have a big enough printer to print it entire components.
And isn't the limitation that the machine can only take so many different raw materials to print? Is that right?
Effectively, that's true, but there's no real fundamental limitation. So whatever you want to make, we have machines that have multiple components. So for example, this little thing here is made in plastic with blue and white. And that was made in one machine. You could make it in multiple and take it out. It was made in one machine you could switch in the blue material to the white material. So there's no fundamental reason that can't be fixed, and when it's necessary, it can be done. But you're right, and typically, like this kind of $200 machine just has one head, and it only has about a platinum of about 10 centimeters by 10 centimeters. So it could make something about this big. Take a long time to make something that big. How long? Days. If it's that large.
Yeah, 4 or 5 hours.
4 or 5 hours, yeah. But all of that's getting better, and there's so much development going on. I don't think there's fundamental reasons you couldn't make one that could print a room. In fact, the concrete 3D printing of houses is basically like a robot spraying concrete with a control system, that can be as large as a house. So there's no reason we couldn't break that barrier, but you're quite right. In reality, we haven't quite got those capabilities everywhere. Who's next? Yeah.
So I guess I'll use this. It's not on. So if you are building something with a 3D printer that requires some kind of complex material, maybe even a simple example like steel that requires a manufacturing process before it can be used, does that mean effectively you have to have a 3D printer that can be like a blast furnace and can add carbon and can make steel in the...
Yeah, you can make steel. Yes, that's a great question. So, steel is a multi-element material that has iron, basic element, carbon, and other impurities which are critical to its mechanical properties. So controlling that is control of the composition and the temperature and the cycling. You can, and they do, control all of those things in one of these machines. So either a laser or an electron beam is used to heat, and you need to get to a high temperature to build steel anyway. So in principle, all these things can be done. I would say when I said quality is an issue, we don't have probably yet 3D printers that can make materials of exactly the same quality as those that are made in large quantities. But that's, again, not a fundamental problem. I possible. We're not quite where we need to be. That's why I said it's going to take some time. But I don't see any reason why this won't be. We can't envision this doing all of that. You had a question, Michael. Sorry. I didn't.
I'm still struggling with the biology.
Yes.
And you mentioned the food. What materials are used?
Food.
Food.
Food. You make food, you put it into nozzles, you control, and you can go down to cell. They're making meat with cells, one by one. But let's get away from meat and just talk about chocolate. Actually, I read an article that chocolate, you can make amazing chocolate concoctions. Because you can, basically you have all the different chocolate ingredients, so you have the whatever, fat and sugar and things, and you spray them in controlled ways, control that completely as you move around. And you can build a 3D chocolate version of you, so when you bite into it, bursts into some, it's very hard to bake something like that. So honestly, chefs are really talking about delivering innovative things, but it's also, imagine that you're some faraway place, you don't have all those tools in your camper van or your space shuttle to actually make food, and you need the raw materials. They don't fake that. They take cells, vegetable cells, and make meat-type things out of that. That's another story, imitation meat. So yeah, it's food, basically. Okay. Yeah. Person. Oh, okay. Well, if it ever would be possible, it's so far from reality, because we don't understand what a person is. We don't understand the brain. We can't just people. I know people work on neuroscience, and they're trying to make artificial neurons. We know so much, we know so little. Will we ever be able to make a brain? I have no idea. But that's so far from. You can make artificial tissue. You can make joints and things of that kind. That's being done. But actually creating a living thing, I don't know. That's way off in the. Hopefully, way off in the future. Yes.
I've read a little bit about this, but I obviously don't understand it. But I'm told that this has had
Yeah.
That this has had. Hold it close. How about that? This has had a significant impact on assembly lines and automobile companies. Is that correct?
Well, I think what's had a big effect is robotics. So the boundary is not so obvious. So robotics has had a major effect on manufacturing already. It's affected the number of jobs that are required. But robots might still assemble by holding parts together. They might assemble by, cutting and so on. So actually 3D printing, where you're really assembling the materials in the production line, is still not a large thing. It is happening in specialized cases. So they're kind of related. Robotics just means you program the robot to do something. 3D printing means program the robot to build materials from the ground up, almost atom by atom. And that's one step further. So that hasn't quite, the thing you're talking about is affected jobs in the car industry, coal industry. Coal mines now, it's robots down there, not people. Whether that's good or bad, it's safer, that's for sure. But it's affecting, but that's related but a little different. 3D manufacturing, you make fundamental materials like the body of the car, or the window, or the engine parts through this ground-up approach versus the old-fashioned machine-down approach. But all of that stuff is already automated. I think if you go to any parts manufacturer, you'll find CNC machines, computer numerically controlled machines, that make most of the fancy parts, and nobody's inside the machine, it's all run by computer. But it's subtractive manufacturing, not additive manufacturing. Does that make sense? 3D printing is adding one more capability on top of all that, building from the ground up, additive manufacturing. That's the revolution I was talking about. I'm not sure if I explained it well.
I'm sure you explained it properly.
No, probably not.
I don't understand.
Okay, but robotics is robotics is the thing that's affected the world today, and it's going to be bigger. Nowadays, robots can do more and more things than humans used to do, and sometimes they're very unsafe things, and robots don't, they don't have, you don't have to be concerned about their lives, for example. That's happening today in a major way. This is probably the next generation, which is how you make things.
Thank
Two simple questions. One, who do you answer to as far as administrative? Do you answer to the president of FAMU or FSU, and who handles administrative expenses?
Okay, great question. So this morning I was at our management council meeting, joint management council. We have it every 3 months. The president of FAMU, the president of FSU, the provost of each university, the vice presidents are there, and the chancellor of the state university system. He's the final arbiter. He runs all the universities in the state. They manage the college. So ultimately, if I can't get agreement, and so far I haven't had this problem between the two universities, I can go to that management council and the chancellor will decide what to do. So that's like, formally we're managed separately. I report to the two presidents, but we do have an independence from the other. Does that make sense?
Yes, that answers my question. Second question, though, it's simple. But Beyond Meat has created this quasi-meat look-alike that's real hot right now, stock is going through the roof.
Yeah.
Is that designed by 3D printing? Do they come up with that artificial meat pattern?
It's a good question. I think I know the answer, but I'm not an expert on this. I think you don't have to use 3D printing. You can make meat by cultivating. So it's not the same thing, but 3D printing is one of the ways to make that. So I think there are other ways to do it by cell culture, and so I'm not an expert in this. But the idea behind artificial meat is that you could use vegetable cells or animal cells that have been made in a dish instead of in a field, and you can assemble them into something with a texture of the meat. Apparently, you can buy it from the store, you can buy it from the fast food places. It's like a burger. And some people claim, well, it has a good economic impact on the environment or whatever. But 3D printing is kind of one step above that, allowing you to shape more complicated things than just a patty. You can actually make a meat chocolate integrated structure if you wanted to. There's some countries somewhere where they probably like that kind of thing. Yeah. Okay, one more question. I want you to demonstrate this. Sorry, is it working now? Would you just demonstrate that also if people would come on? So what he's got is a scanner, and you're seeing it on, you see something, you can explain it?
Yeah, so here,
So
this object here is from a company Creaform. It's called a Handy Scanner Black. And so normally if you want to create a, do you have a microphone?
There, it's there.
Oh, it's called. Hi, so normally if you want to, for example, create an object to use with a 3D printer, you would design this on the computer. So you use a CAD computer-aided design program. As you would draw this object up on the computer and splice that object into readable code that the 3D printer can read, and it will recreate the object that you make on the computer. But what happens a lot of times is you have a real object and you want to make a copy of it. So for example, if I have something like this, this is basically just a small object used to hold pins if you want to solder things. So it's just an extra set of hands to hold wires. But if you wanted to 3D print this, you would have to make measurements of every single part of this circular object. And so this would actually take you maybe 5 or 6 hours to recreate on the computer if you knew all the dimensions. And it would take even longer to accurately measure all the dimensions of that component. But what the scanner does is it actually lets you create 3D representations of any object that you see in the world. So these reflective dots can either be placed on a table or you can place them on an object. So if I want to create a 3D scan of anybody in here, you can sit very still, you can put some dots on your face and create a 3D scan of your body. And so here I'm just going to demonstrate the actual product. And then at the end, you guys can come up if you have time and 3D scan whatever you have. So on this table, we can put anything that will fit in those dots. You can actually scan the entire table if you want, or the piano. But yeah, it's up to you guys, so I'll just give a quick demonstration. So here, initially, it basically looks at these reflective dots, and the scanner knows where it is in real time. So up on the screen, this is like an exact replication of how I'm positioning the scanner. And so this is the initial calibration stage. It's a little bit tricky to do, but I'll quickly run through the calibration stage. basically here we're just kind of calibrating the real 3D space. So the scanner knows how to view objects in 3 dimensions. See, it's a little finicky to initially calibrate it. But once we're finished, we'll be good to go. Scanning. Okay. All right, so now we're basically free to 3D scan any object. So I'll go to the front here, and I'll basically scan.
Randy, put your face in this. That's great.
And so here it looks for these initial pins. And so it's kind of just finalizing the calibration. That. And then I'll go ahead and confirm on the computer real quick. Okay, so here we can actually do any type of 3D scanning. So here, what you can see is it picks up the reflective dots on the page, and then if anything inside of these dots, it will let you 3D scan to create the representation. So here you can digitally zoom. You can actually change the frequency of the lasers that are being emitted out of the machine. So you can kind of look at this. It's safe to view without protective glasses, but it emits high frequency lasers, and it uses that to scan any object that you have. So this is probably the most advanced scanner that's handheld that you can buy in the world right now. And so you can basically use this to create 3D representations of any object. A lot of people will use this if they are working in aerospace and they want to replicate the inside of a cockpit. They will use these types of scanners to do that. Of course, if you have specialty parts in cars and you want to replicate those, you can use this scanner to easily make copies of basically any object.
People come up and you can...
Yeah, so I mean, it's very simple. So as you can see, we basically already have a 3D scan of this object. So if you guys want, you can come up and we can throw anything on the sheet of paper.
Your finger?
Yeah.
You can stay steady.
Yeah, if you can stay steady, you can scan any object. Yeah.
All right, so we'll just stop there. Anyone can come up and look at the printer and thank you.
Just to give some remembrance for you, this is our Rotary Club Tallahassee history book, and you'll find many leaders are local in Scotland. So, there you go. And our.
Do you have anything else?
Let's recite our four-way test.
Want a different object?
Yeah, so let's do the camera.
Camera.
We can do that.
Too big?
No, it'll work.
Recite our Rotary theme for the year. Rotary protects the world. Miniature.
Very detailed.
Oh yeah, you do the launch? What I should have done was brought business cards, and I can 3D print stuff.
Mr. Jackson, are you a student or a faculty member?
A student.
You're a student. What year?
This is my second year for PhD.